Hello, it's Mr. Schwannekamp. We are doing a section on quadratic formula. So this should sound familiar. I don't think you can get through Algebra 1 without thinking about quadratic formula quite a bit, and they talk about it quite a bit. You'd probably spend a whole week on it. We're not going to spend that long today, but it's doing the exact same thing we've done in the last couple sections. So far we've learned about solving using factoring or quadratic formula, or I'm sorry, solving or factoring. Today we're going to do a similar thing using quadratic formula. The reason quadratic formula is nice is because it always works. No matter what quadratic equation they give you, you can solve it using quadratic formula. Is it always the most simple steps? No. There's some algorithmic things to it, meaning like we got to plug in and do this and do that and do this. But it always works, and so that's pretty nice. It's something that I used to do when I was a student. It was by far my favorite thing to do just because I always knew it was going to be the right answer. Sometimes with factoring, you got to guess and think what multiplies together, but when we do quadratic formula, it's always going to work when we set it up. So let's get to it. So when we do quadratic formula, this is quadratic formula right here. All right, this x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That is something that you probably need to memorize. Probably more than anything else in Algebra 2, you should memorize quadratic formula. All right, in this quadratic formula, and we'll explain it as we go, we've got this part right here, this b squared minus 4ac. That part right there is called the discriminant. Okay, the discriminant, the thing underneath the square root, will tell you what your roots are going to look like. So again, remember what a root is. A root is where your graph crosses the x-axis. So every quadratic is going to have two roots, but there is some different things with that. So here's what could happen. You could have a parabola that looks like this, and if we do, you have one solution, two solutions, pretty straightforward and easy. You could have a parabola that looks like this. We only have one solution, but it counts as a double root. For example, if this were to happen right here, it would be like x plus 4 times x plus 4. Oh, I'm just playing. X minus 4, x minus 4. Technically, it only has one root of 4. It just happens twice. And so that is what's happening there. So that could be true. Or a third thing could be true, which is this parabola right here. It does not cross the x-axis. And so you might think that there's no roots, but the answer is there's no real roots. You're going to get imaginary numbers, and that's what we'll learn in the next section. And although that seems crazy, it's not as bad as it seems. All right. So the discriminant is going to tell us what category we fall into. Okay. You could have one root that's doubled. So again, that's this picture right here, where it touches that line. You could have two real roots where it crosses, or you could have no real roots where it does not cross the x-axis. Remember what a root means. We've talked about this a bunch now. A root means the solution. The x-intercepts, or the zeros. Sorry, my brain stopped working. Or zeros. All of those words mean the same context here. So make sure we understand what's going on. All right, so we're going to find the discriminant, the number underneath the square root in quadratic formula. So that is the negative b, I'm sorry, just kidding. I started writing the whole thing. B squared minus 4ac. B squared minus 4ac. That's this guy. So remember what that is. This is, in this problem, my a is 1, my b is 4, my c is 4. Let's plug it in. So we're going to go b squared, so 4 squared minus 4 times a times c. So I get 16 minus 16. I get 0. So then we're going to look up here and remember which category that falls into. If you do the discriminant and you get 0, that means we are going to have one double root. I'm not going to just say one root because we've talked over and over again. If it's squared, you're going to get two answers. And we are. It's just going to be repeated. So this one has one root. It just happens to be doubled. If we do it on this one, b squared. So 5 squared minus 4 times a times, I'm doing a bad job here because it's not equal to 0. It needs to be equal to 0. So if I'm going to make it equal to 0, I got to subtract 3 from both sides. That would get me 0. So this is really minus 6. So b squared minus 4 times a times c, where my c is negative 6. I get 25 plus 24, because negative 4 times negative 6 would be positive. I get 49. Since the discriminant is positive, I'm going to have 2 real roots, meaning it's going to cross the x-axis 2 times. Last thing we got is this one. Let's try it. B squared, so negative 6 squared minus 4 times a times c. 36 minus 40, I get negative 4. If I get a negative number for my discriminant, I'm going to have no real roots. Again, why is that? Because you're going to have a parabola like that that's above the x-axis, so it's not going to cross it in our normal plane. All right, so that's the basics. That's the discriminant. And what we're doing here is I'm giving you a little bit at a time, a little bit at a time. So now let's learn how to simplify quadratic formula. Eventually, when we plug into this big guy up here, your answer is going to look something like this. And all we're going to do here is practice simplifying. So when I see this, 4 plus or minus the square root of 16 all over 2, the first thing I'm always going to do is work with the radical. I've got the square root of 16. Well, the square root of 16 is just 4. So that makes this problem pretty easy. I get 4 plus or minus 4 divided by 2. The plus or minus means I'm getting 2 different numbers. I've got 4 plus 4 divided by 2, and I get 4 minus 4 divided by 2. If it's a real number like the number 4, a whole number like the number 4, we're going to go ahead and break this down. So 4 plus 4 is 8 divided by 2. One of my answers is 4. If I got 4 minus 4, I'd get 0 over 2. 0 divided by 2 is 0. So we got 2 solutions from that because one of them was plus 4, one of them was minus 4. That's the best situation. That one's the one that's the easiest to handle. It's going to be similar here to number 5. So I've got the square root of 81. Oh, that's 9. All right, cool. It's a regular whole number. So since it's a whole number, we can go ahead and split this up into 2 problems. Negative 3 plus 9 divided by 6. That would be 6 divided by 6. That's 1. Boom. There's one of my answers. Then we could go negative 3 minus 9 divided by 6. That would be negative 12 divided by 6. Oh, that is negative 2. There's my second answer. And we're always going to get 2 answers from quadratic. Or two solutions. They might not always be real solutions. Let's try number 6. So number 6, I can't take the square root of 28, but I'm still going to come over here and simplify the square root of 28, just like we've always done. Square root of 28, I can break that down into 14 and 2. 14, I can break that down into 7 and 2. I can't break down 7 anymore. That's a 7, not a 2. It looks like a 2, though. All right, so I'm looking for pairs. I've got one. I've got a 2 that can come outside the radical. The 7 cannot. So this time, I'm not going to split it up into two separate problems, a plus and a minus problem, because it doesn't make any sense to. Instead, I'm going to just write in that 2 radical 7 and see if I can simplify it. In order to simplify this thing, I have to be able to simplify both values by 2, not the number underneath the radical. Okay, we don't simplify with those numbers underneath the radical, but can I reduce 6 by 2 and 2 by 2? And if you can, then we can rewrite this setup. So negative 6 divided by 2, that is negative 3. Plus or minus is still going to be there. And then 2 divided by 2 would be 1 radical 7. And obviously, you don't need to write that 1 there. I'm just going to leave it as radical 7. And so what we did is we simplified the radical, and then we reduced both things. If you can't reduce them both, then you can't simplify. But since I could divide them both by 2, I did. Let's look at example 7. So again, square root of 32, that's not a whole number. So we're going to break it down. 32 breaks down into 8 and 4. 8 breaks down into 2 and 4. 4 breaks down into 2 and 2. 4 breaks down into 2 and 2. All right, so I I broke those all down. I got a pair of 2's. I got a pair of 2's. I got a 2 left over. So since I have 2 pairs of 2, I'm going to multiply them together and get 4, radical 2. So I get this, 8 plus or minus 4 radical 2 all over 4. Can I reduce this number and the number in front of the radical? Okay, if I can reduce both numbers, then I'm going to do that. So I'm going to try to reduce both of them. So 8 divided by 2, oh, that's 4. Plus or minus 4 divided by 2, oh, that's 2. Radical 2, that is my answer. Again, that is 2 answers because one of them is positive, one of them is negative. Now let's put the whole thing together here. Okay, we're going to do this whole concept here. Up here on the top is just talking through the same thing we already did. Let's just do it. All right, so I'm going to write down quadratic formula just so you see it. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, let's set it up. So my a is 1, my b is negative 12, my c is negative 28. So negative b, so negative 12 would be positive 12, plus or minus the square root of b squared, so negative 12 squared. Often when I square something, I don't even write the negative sign here, because if I square it, it's automatically going to be positive. And so just to avoid a mistake, I just write positive 12. Minus 4 times a times c, negative 28. All divided by 2a, so it's 2 times 1. There's my setup. All right, so the next thing I'm going to do, once I've written it out, we've already done this whole problem, or at least all the different steps. The next thing I'm going to do is work on the discriminant, the thing underneath the radical. So I've got 12 squared, that's 144. I've got a minus sign and a negative. These are all being multiplied together. Remember, it's 4ac, so negative 4 times 1 times negative 28. That's going to be positive. And then all we got to do is figure out what 4 times 28 is. All right, so if you're not great at this, we could use our calculator here, but I multiplied those together. I got 112. I'm going to add 144 plus 112. That gets me 256. And I'm square rooting that. And that might not be a number that you're good at. That might not be a skill that you've got, but you've got a calculator. Take the square root of 256. That is going to get you 16. I didn't have to break it down. It's simplified correctly in terms of a square root. And so we've got a whole number here. So because I got a whole number, then we're going to keep going with this problem. 12 plus or minus 16 divided by 2. Why did I just went against what I just said? Because it's a whole number, we're going to break it down into 2 problems because it's going to be easier to see. 12 plus 16 divided by 2 and 12 minus 16 divided by 2. 12 plus 16 is 28 divided by 2. That is 14. That is one of my answers. 12 minus 16, that is negative 4 divided by 2. That is going to get me negative 2. That is my other answer. That's what I'm looking for here. Okay, so it's a long problem. It's not an easy thing to do. It's not something that you're going to be perfect at every time. Let's show you what this means. Okay, because I think a lot of times we do math and we forget what it means. Let's look at it. So x squared minus 12x minus 28. Okay, what we just found by doing this problem is we found where this parabola, because if I zoom out far enough, and I got to zoom out quite a bit, it was a parabola because it was x squared. What we found by doing quadratic formula were the 2 places that we crossed the x-axis, the 2 x-intercepts. There is one. It's at negative 2, just like we found. And where's the other one? It's at 14, just like we found. That is what quadratic formula tells us. It tells us the solutions, the roots, the zeros of that graph. Let's try one more. All right, so we look at letter B. The first thing I hope you recognize is that it is not equal to 0. Again, just like factoring, if we have a trinomial, x squared, x, and a number, in order to solve a trinomial, we need to make it equal to 0. So the first thing I'm going to do is I'm going to add 64 to this side, Because if I add 64 to this side, now it's all equal to 0. Once we've done that, we're going to do quadratic formula. So it's negative, again, negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b, so negative 6 plus or minus the square root b squared, so 6 squared, minus 4 times a times c all over 2 times my a value, which is 2. Great. We're going to start simplifying. So I'm going to do underneath the square root first. We're going to do the discriminant. So 36 minus 4 times 2 is 8. 8 times 4 is 32. 36 minus 32 is 4. We square root that. We get 2. So negative 6 plus or minus. Yeah, I did it again. Why do I keep doing it? Because it's a whole number. Let's split it up. Negative 6 plus 2 divided by 4. And negative 6 minus 2 divided by 4. Negative 6 plus 2, that is negative 4. Over 4, it's negative 1. That is negative 8 over 4. That is negative 2. Those are my two solutions. Now, these two problems are a little bit more of the basic version of quadratic formula. We could have just factored each of these and done just as well. All right, we could have factored this one right here and done some borrow and payback and solved it the same way. So if I would have borrowed that 2, I could have factored x plus 4, x plus 2, divide by the number we borrowed at the beginning. So we borrowed the 2, so now I'm going to divide by 2. I get x plus 2 and x plus 1. Hey, guess what? It got me negative 1 and negative 2 like I thought. We could have just factored, which is easier than quadratic formula. But quadratic formula is great for problems like this. You couldn't factor this, okay? These types of problems where you get these really ugly answers in the end, you can't factor them, and that's why we need quadratic formula. But we tried to start off with some simpler ones to get a better idea of what's going on. In the next section, we will try to examine some more difficult questions, but hopefully that makes some sense to you. All right, as always, if you have questions, ask me.